Hello everyone. Today I want to teach you about MergeSort. So at the end of the last lecture, which was lecture 2, you learned some basic sorting algorithms, and so today I want to teach you one specific type called MergeSort and walk you through the algorithm, and so hopefully by the end of this you'll be able to implement it by yourself. So the idea is, if we want to sort a list of numbers, we could sort the entire thing, but if we're not quite sure how, we could just sort one half, sort the other half, and then merge the two results together. And so we could first sort 12, 13, and 5, and then we could somehow merge that after we've sorted 9, 6, and 7. But then, how did we get this and how did we get that? We could also break this into 2 and this into 2, and then we could first sort 13 and 5, and then put this together, and then we could sort 9, 6, and 7. And if we put this together, and then put them all together, we would have sorted the entire thing. And so if we sort this, it would be 5, 13. And if we sorted this, it's already sorted, it would be 6, 7. And then we can recombine this to 5, 12, 13, and this to 6, 7, 9. And then finally we could merge these two halves, and we get 5, 6, 7, 9, 12, and 13, which is the sorted version of the thing that we started with. And so this is kind of the process that MergeSort will take us through. So at this point you might be asking, why did we have to break it into 2 and break it into 2 and keep on breaking it over and over again if we're just going to merge it back together eventually? And the answer is that actually sorting each component and then merging them back together saves a lot of time. Because think about it, if this is already sorted, you know that 6 must be the least in this half of the array. And if this is already sorted, you know that 5 must be the least in this half of the array. So if you merge them together, you know either 5 or 6 is going to be the least in the entire array. So it saves a lot of time that way. You don't have to compare 6 to 5, 12, and 13, you only have to compare it to one value. And so this actually speeds up the process. So actually breaking it down into littler parts and then working with those already sorted arrays speeds up the process. So now that you know the basic concept of how MergeSort is going to work, let's look at the code above here. So it's called MergeSort, and it will take in an array. And so we're saying that if the array has a length greater than 1, and the reason why we're testing for this is because if it has a length of 1, then it's already sorted. So we don't really have to do anything with it. So if it is greater than 1, we can find the middle of this array. We can basically chop it in half. And this is what this says. It takes the array, takes all to the middle, from the very left to the middle, and calls that left, and from the middle to the very right, and it calls that the right half. And then what it's saying is, okay, we can sort this half, we can sort this half, and then we can put them back together. So we can sort the left, we can sort the right, and then we can merge the left and the right back into the array. And so basically it's going through this process. Now the harder part is exactly how it remerges two sorted lists back into the greater array. And that is handled by merge here. So let's look at two potential things that we might merge. 5, 12, 13. And 6, 7, 9. So once it gets to this point where it has to merge, it's already been sorted. So these are two sorted lists that are going to be needed to merge. So it initializes I, j, and k to 0. So what's that saying is, okay, this is going to create an array. It's going to have the length of these two combined, 1, 2, 3, 4, 5, 6. K will place to where it wants to put it in this new array. I will point to the index it's looking for on this array, and j will point to the index that's looking on this right-hand of the array. So while I is less than the length of L and J is less than the length of R, so intuitively, if J exceeded this, then it wouldn't point to this half. So once it gets to here, we don't want to consider that case. And once this is greater than the length of this, then we can't compare them anymore because this doesn't point to a value. So if Li, which is basically this value, is less than the right value, then it's saying the array, the result, k, we should just make it the littler value, which would be 5. So then this would go here. And then it would increment I by 1, so it's saying we're done with the 5. We can move on to the next number and start comparing that. And then after that, it says, okay, we're done placing anything. We can move k over 1. And then we can repeat this process, but now we're looking at I for 12 and j for 6. And then we'd see, okay, this time it's j that's littler, so we put j here. We move j to the next spot. We move k to the next spot. And that's what this k equals k plus 1 does, and that's what this j equals j plus 1 does. And then we find 7 is less than 12, so by the same process, we put 7, we move it over, we move k over, and then we compare j and I, which is 12, and the 9 is less. So we move this over, and we move this over here. But now we see that j is not pointing to anything. So we're done with this while loop because j is now greater or equal to than the length of r. So now we have to sort of do the corner case where, okay, if we're done going through all of these values in the right-hand array, then we know that the remaining values must all come from the left array. And since they're already sorted, we can just slot them in. So we can just say, okay, increment I, put I in, and increment I, and increment k. So put it in, move to the next one, and move to the next one, and it would just copy the remaining values of the left array over here. And then you'll see that we arrive at a sorted list. And so, thanks for watching. The last thing I wanted to do is just show you how the implemented code looks. And so as you can see, we did exactly what I showed you. You have the left, the right, you merge it, and then combine the two. And at the top, you have the same merge thing, I, j, k, where I is the index of the left-hand side, j is the index of the right, and k is the result index, and this whole process of comparing and incrementing. And so if we run this, we can see I just ran it on the example that I showed you, and it will give us the sorted array. So I hope now you know how MergeSort works, and now you can implement it on your own. Thank you.